Okay, hello everyone. My name is Toni. I work as a senior engineer at UpCloud to improve our developer experience. So, for example, working with our Terraform provider and Pulumi provider that we are talking about today. Goal is to use as many UpCloud products as possible for this kind of orchestration scenario. I'm an engineer, so obviously the title wasn't created by me, but our marketing team, but the presentation is by me. And what we are gonna do, let's first talk about why Pulumi, and I have a couple of Terraform examples because that's the scenario when you're thinking about is there a better way to do these things. Then let's see what's Pulumi and how do the providers come into life. So how we have created our provider and how other cloud vendors are creating theirs. And I have a demo as well. That's where we'll be using the UpCloud products. And let's actually take a sneak peek at the demo because it's gonna take 15 minutes to set up those resources. And we don't wanna do that live, but let's look at the presentation while it's loading stuff. So what I have here is a lot of code on the window. And I'm using TypeScript for the demo. Pulumi supports also Java, Go, Python, and C#. But from what I've heard, TypeScript is the most approachable of those. So if you know TypeScript, it's probably the easiest one to use with Pulumi, at least in my opinion. I also tried the Go code, but it's a lot clumsier than the TypeScript in this kind of infra as a code scenario. And what I'm gonna do before we go into the slides, I'm gonna run Pulumi up. That's like equivalent of running Terraform apply. Before that, I have installed the UpCloud provider with npm. So like any other JavaScript or TypeScript package. And well, you can see the imports there. So where the code is coming from, or the dependencies are coming from. And I'll create the new stack for us, which is equivalent to Terraform state. So it holds what we have in the cloud, status of all the resources and what's the relation between those. And well, if you have used Terraform, you know that when you run Terraform apply, you get a summary of what you're gonna get. Pulumi does a similar thing. In this case, it's in the scroll back because I have a limited screen area here. Okay, that was too far. But yeah, we get a list of things we are going to create. So I'm going to use Kubernetes and a database to set up an application. And for that, I also need some networking stuff. So gateway, because we don't want to have our application directly accessible from the internet, but have something of a barrier between the application and internet. So we have a private network for the worker nodes of the Kubernetes cluster. Then a router for the Kubernetes control plane to access those worker nodes. And well, database, and then a bunch of Kubernetes resources for the actual application. And well, if you are deploying an actual application, you might want to see the detailed output of what you're going to create. That's also possible with Pulumi. But I have deployed this obviously a couple of times before to test that it works, so I know what's happening. So I can click yes here. And it's going to create a bunch of resources in UpCloud. The Kubernetes cluster will take about 10 minutes to spin up. So we can either watch the counter go up or go back to the slides. And it's not interesting for the rest of the 10 minutes, so I'll hop back to the slides. Starting with why Pulumi. I'm guessing that no one of you attended HashiCorp user group meetup in Helsinki about 2 years ago. And that's good because I'm going to be reusing the slides, which might cause a bit of confusion because Pulumi is not a HashiCorp product. I was talking about Terraform CDK back then, which is a very similar tool. So Pulumi and this kind of programming language tools for creating infrastructure are definitely not a new thing, but something that's gaining a bit of attention every few years. And well, the Terraform CDK, I haven't heard back about that one in a while. We still have the provider going on, but we don't really hear from many users of that provider. But the problem persists. So if you're using Terraform, you might have to use some tricks to add some conditions to your configuration. So if you're, for example, creating a reusable set of resources, you'll usually have some resources that you need conditionally. For example, if we didn't use database, we might run the database as a pod in the Kubernetes cluster. In that case, we would need a persistent volume claim for the pod and a service and the pod itself. And in that case, with Terraform, we would usually use that kind of count variable. So instead of deploying one persistent volume, we would be deploying 0 of those, which will look a bit confusing in the logs because you get a log note that the persistent volume claim has been created. Well, there's 0 of those created, so it's a bit misleading there. And this is something that we can better address in a programming language file because we could have a if-else logic there. So if we want to create the resources, then define those. If not, then just skip the block there. And it might be even more confusing if you need to do some actual logic in the Terraform. You can use local variables for that, but good luck seeing what that does on a quick glance. Well, you can make some guesses based on the variable names. You get the URL of the application, but it's not really a pretty way of getting that information out of the configuration. And this one we already started. So what is Pulumi? Pulumi allows defining your cloud resources or, well, any other computing resources as a programming language code. As mentioned, works with TypeScript, Python, Java, C# and Go. And very similar to Terraform CDK that I mentioned in the beginning. But lately, Pulumi has been getting a lot more attention. We have many customers that have reached out to us and asking if we have a Pulumi provider. And well, now we do. And well, comparing to the Terraform CDK, Pulumi is a bit more advanced. So where Terraform CDK use the programming language code to create Terraform configuration, Pulumi provider will directly call the cloud endpoints. So with Terraform, you get the configuration that you have to use. So for example, if you have inputs to your configuration, you cannot access them in the programming language code. But with Pulumi, you can get the inputs and use them in the conditions. So it's a much nicer experience. And similarly to Terraform, Pulumi uses providers to do the actual calls towards the cloud provider. And the Pulumi providers can be either native, meaning that the provider is written directly for Pulumi, or bridged, meaning that there is a Terraform provider that is used to generate the Pulumi provider. And in our case, our provider is bridged, so we develop the Terraform provider and then automatically generate the Pulumi provider based on the Terraform provider, and it actually works quite nicely. We get all the resources we have in Terraform, all the data sources we have in Terraform, and all the examples we have in the Terraform provider are automatically converted into the programming language codes. So if you look into the documentation somewhere here, for example, for the Kubernetes cluster, we have a nice example on how to use it. It's auto-generated, so there might be some hit and miss stuff that doesn't work out of the box. But it's a good hint on how things should work. And you'll find our provider in GitHub as well. It's mostly a configuration code, and then the Pulumi scripts do all the hard work for us. And if you want to see how this demo is done, it's here in the Pulumi App Cloud GitHub repository as well. So it's the same code I have open in the VS Code. Some last minute fixes right before the presentation. You cannot hide in the GitHub view. But yes. So Pulumi released it's a beta feature at the moment. So you can take any Terraform provider and use that as a Pulumi provider. I have that open here as well. So it's a Terraform provider named tool that you can use to download the Terraform provider, and then Pulumi will create a TypeScript or Python library based on that. And that one also seemed to work nicely. I think they use the same logic as they do for the self-hosted providers like ours. And well, for example, the Terraform provider random is the one that they use in the examples. So a very simple one, but so comparing Pulumi to the CLI or the native SDKs, with Pulumi you get the benefits of managed solution. So you have automatic dependency tree building. If you define multiple resources, Pulumi will figure out which one has dependency where. And for example, I have defined network and router and gateway. It will see that the gateway references the network and router resources. So it creates the network and router first, and then the gateway. Whereas if you're using the AWS CLI or UpCloud client or any other cloud provider's client, you have to know yourself what's the order of creating things. So depending on your use case, might be a great help. Or if you know what you're doing, then obviously the client or native SDK works nicely as well. So yeah, with Pulumi, similar than with Terraform, you get a bit more automation into the play. So you don't have to manually know every dependency. Of course, Pulumi is not perfect in figuring those either. For example, here in the code I have depends on. So similar than with Terraform, you can also manually tell the dependencies. In this case, Pulumi doesn't know that the application running inside the Kubernetes cluster depends on the Kubernetes cluster, because we will be using a data source to fetch the credentials for the Kubernetes provider. So there is no direct connection between those two resources. And well, in this case, the problem is only when deleting the resource, because the data source has a dependency to the resource, so you don't get the credentials before the Kubernetes cluster is live. But then when deleting, well, the data source can be deleted right away, but the application running in the cluster doesn't know it's depending on the cluster, because there is no connection between those in the code. Obviously, there is a connection in the application level. And well, another example, so similar than with Terraform, you will have some reusable code. With Pulumi, instead of module doors are called packages. So for example, I have an application as a class, which we will then use to deploy the actual application. So those Kubernetes resources. And don't know how visible this is to the back row, but cannot zoom any closer, because then we would have like 3 words per row. But let's see an example how these resources are defined. So we can use Pulumi configuration to get input values to our code. In this case, for example, the database plan and the network addresses to use. And well, we could obviously configure anything related to our infra here. And in case of Pulumi, we can actually use these values in the code, so we can have a if-else based on these values. Not sure if I have any more. Can't remember. Well, there's one example. So for example, when we are creating the load balancer, or the way to reach the application, if you are using load balancer, you can use HTTPS connection, because then the load balancer type service will automatically create the certificates for us. And if you're using a node port, then let's use HTTP, so that we don't have to configure the certificates here in this example. And seems that this is running a bit slow, the example application on the database side at least. Yep. So we have the database defined as a variable in the code. So in that sense, we know that there is going to be the dependency from that database to something. And well, in this case, we will need the database connection URL in our application. So we can see from the code as well that there is going to be the dependency if you need a variable for the resource. Yeah. Yeah, similarly than with Terraform, you have a variable name or resource name for every resource you have that you can use to reference the references in configuration for other resources. But you don't have to like be so strict with the order of creating stuff. Well, with TypeScript you have to, because the order of creation is the order of where the variables are defined. But that's not the case with all of these programming languages. Or maybe it is. But yeah, if you would define this with TypeScript using our, well, we don't have TypeScript SDK at the moment, but if you will be using our Go SDK and defining it manually, you would have to have those like wait until this resource is ready, logic yourself, wait until the Kubernetes cluster is ready so that we can use it as an input to the application. So those sort of wait until and like that sort of dependency logic is the like biggest benefit we get from the Pulumi provider. And obviously if you have that implemented in your SDK, then that's there. But with Pulumi, that's required. So every provider will have those, because otherwise you will get a bunch of errors in the like resource creation phase. Uh, so how to test these configurations? And well, obviously you can use any testing solutions provided by the programming language. So we could use JavaScript's testing tools to test the code with unit tests. But obviously in that case you have to take that into account when creating the configuration. So it might be easier, might be as difficult as with Terraform, depending on how you're approaching the problem. So for example, in this case, we have these dependencies. For example, the load balancer will be created. In some cases, that sort of logic is easier to test because it doesn't actually create the resource in the cloud. But having worked with the Terraform provider, usually easiest way to test the provider is the way that takes the most time, because we get a lot of help from the Pulumi or Terraform, so the application running or provider, and testing that part is obviously difficult with this code only. So the testing is definitely a challenge, both with Pulumi and both with Terraform as well. Seems that we have a demo effect with the database. Usually takes like 10 minutes or less to create that one, but it's probably doing some rebuilding there in the background. So what happens if we then try to recreate this whole setup? Let's try. So canceling the update, or create operation in this case. Let's try to run that again. And Pulumi should notice that everything else is up to date, and we only it stores the state by default on your machine. They also offer a cloud-based solution for storing your data in their cloud, similar to Terraform and HashiCorp. And well, so in this case, it detects that we have 13 unchanged resources, so those that were created successfully, and well, the database, and then the API application that has dependency towards the database are now missing. And if we click yes here, it will start creating the resources again. And in this case, because the database creation didn't succeed, it didn't end up in the state, and the database prefix has to be unique, so that one fails now, and we are trying to create it again. So, are we restricted by the Pulumi providers? No. And for example, in this case, I'm using the Kubernetes client as well. So we get the kubeconfig from the UpCloud provider, and then use that both to create a Pulumi Kubernetes provider and Kubernetes client, because the Pulumi provider doesn't have an option to list nodes that we need to for getting the IP address of those. So we can use also other tools or anything you can write with TypeScript or Python or Go. So in that sense, it gives us more opportunities to fetch data from the resources. For example, this Kubernetes client is used to fetch initial admin password. So the application would have created a Django application, and that one has an initial admin password that we are writing to the disk of the pod, which we could then read with the kubectl command, or well, equivalent of that in the TypeScript API. So we also get access to these additional features provided, for example, by the SDK that are not available in the Pulumi provider more easily. Of course, it's possible to hack those into Pulumi or Terraform configuration as well. So how to maintain multiple environments with Pulumi? In Pulumi, the name for the environment is stack. So we have a pulumi.yaml file for each stack that we have. Or if you're using Pulumi Cloud, then you would have these in their cloud system. So you could have a dev stack, test stack, and a production stack, and manage those separately, and select which stack you are using for which operation. So you could first roll out the changes to development stack, then to testing stack, and finally to production stack, or depending on what's your workflow. So I find that a bit more nice than with Terraform, because there you have to maintain that a bit more manually. Well, depends also on tools you use. If you use the HashiCorp's cloud platform, then you get more nice things, but then you're restricted by the commercial solutions offered by them. Yeah. So how does the Pulumi and open source go together? The Pulumi tool itself, it's open source, like Terraform was a year or two ago. So you can use it to configure your application, and then they have like value-add services for storing this data and managing your secrets and that sort of stuff. So no fork of the tool for open source part, but it's the same tool that you can use. I haven't actually checked what's the licensing they use, because most of our customers have been interested in the tool only and not the like state management solutions. Like if you're using Terraform and you have like non-HashiCorp state management system, then you're probably using, or the state manager is using OpenTofu in the background instead of Terraform. And well, I'm not going to show the demo application because the database creation failed. It would have been one more QR code. We probably have enough of those anyway, so not confusing you with that. In this case, the code is available in the Pulumi App Cloud repository. And if you want to see the example application, that's in GitHub as well. And that's it. I forgot to mention that we want to take the questions at the end of the presentation for the video to work nicely. But if you have any other questions, last chance. Yep. It's a US-based company from Seattle. So I haven't actually no idea how to pronounce it properly. But if you heard it for the first time, then Pulumi is now the Finnish way of saying it. I was supposed to check the pronunciation before this presentation, but I forgot. We have been talking about Pulumi, but might be that there is a more American way to pronounce it properly. Yeah, it's a Seattle-based company formed by two Microsoft, like ex-Microsoft people. And yeah, we use our Terraform provider to provide support for Pulumi users through that bridged Pulumi provider code generation tool. So it works nicely for us, a cloud provider, because we don't have to write the clients or the implementation ourselves, but we can use the Terraform provider to automatically generate that. Thank you for listening. Thank you.